The theoretical benefits of additive manufacture. This is also known as 3D printing generally. That's how it's mostly known by the public. It's distributed manufacture, so it takes a digital file, essentially, if you like, a computer-aided design file, transmits it over some appropriate data link, straight into a 3D printer, whatever the technology is, and that printer then, essentially using a layer upon layer process, takes a raw material, usually in the form of a powder or a filament, and creates layer by layer a complex 3D object. And it has instinctive appeal, I think, to a defence logistician, because in very simple terms, if you've got the means to do the production, the manufacture in your hands, literally there at the front line, you've got theoretically huge control. You know, you've lost all of that physical supply chain that could go for hundreds, possibly thousands of miles into the distance, and you've got it here in your hand. So that's very tempting. It's very attractive to maintainers in particular. And because it's digital inventory rather than physical products, if you consider that a defence supply chain, especially out to an operational theatre, can be very long, it can cross over international borders, it can be very vulnerable to hostile enemy interdiction, it can be vulnerable to political interference, for example. Closure of border crossings is a classic case. If you imagine that digital inventory kind of misses all of that out, then that is a very attractive option to a defence logistician. You get rid of all of that vulnerability and complexity. And I think finally, or probably quite significantly, to a defence logistician, additive manufacture kind of instinctively enhances their traditional ability to improvise repair. It gives them an extra tool set, which is very attractive. Well, of course, the theory is one thing, but reality bites soon enough, and we need to be realistic about this. Additive manufacturing has its origins in rapid prototyping, and that is quite distinct from a product that is being properly designed, manufactured, tested, validated, subjected to appropriate quality assurance inspections and so on. And at the moment, the quality assurance aspects of additive manufacture are a little uncertain. That's very important, for example, in achieving airworthiness certification. If you cannot guarantee the quality of the product, you cannot, even really in circumstances of emergency and great stress, it's very risky to consider implementing an AM product and putting it into, for example, a flying helicopter or fixed-wing aircraft. There's too much risk. There is a significant lack of standards in additive manufacture at the moment. There is also variability in the quality of the raw materials, variability in the quality of the 3D printer technology itself. And actually, although additive manufacturing can produce very complex products, that complexity is not yet matched by the inspection and quality assurance technology. So it becomes literally impossible to test the quality of this super complex product that you've just printed. AM is also primarily about one-off production rather than volume. And so I think I would say that it is currently unlikely to significantly reduce the physical products in any significant volume moving down the defence supply chain.